Hey everybody, Mr. Piercy here, and we're going to be looking at today in the video properties of inscribed angles of a circle. So if you're going to follow along with the demonstration, you'll need a compass, a protractor, and a pencil to see what the properties are. To begin with, we're going to start by making a circle. Nothing too huge, but something big enough that will allow us to measure some angles on. So here we have a circle, and I'm going to go ahead and call this circle B, just to give it some kind of label here. What I'm going to do is I'm going to pick two other points on the circle that I will label A and C, and we're going to draw in the central angle ABC. Now that I have my central angle drawn, I want to measure the angle, because remember, the measure of a central angle, so in this case ABC, is going to be equal to the measure of its intercepted arc, AC. And we want to know what is the measurement of that angle, and therefore what is the measurement of the inscribed or the intercepted arc. Now here on mine, this looks to me right about, it's a little short here, so we can say it's about 81 or 82 degrees. We'll call it about 82 degrees just to be on the safe side here. And now what I'm going to do is I'm going to create something called an inscribed angle. Now keep in mind, an inscribed angle is an angle whose vertex is going to be on the circle itself. So I'm going to pick a point down here, and we'll call this point D. Now the thing is the reason why I'm creating the central angle first is because we need to have a reference, something to compare the measurement of the inscribed angle to. So now I have constructed central or inscribed angle ADC. So now I want to know what is the measurement of angle ADC. So again, with my protractor, I'm going to measure the angle here, and you can see here it's not quite 40 degrees. Let me go ahead and zoom in a little bit so we can see that angle measurement a little bit more clearly. On mine here, it's a little bit more than 40 degrees. When I follow it out here, it's right about 41 degrees. So here, the measurement of the inscribed angle is 41 degrees. And the whole point of having the central angle as a reference is that now you can very easily see the measurement of the central angle and the measurement of the inscribed angle. There's a clear relationship. The measurement of the inscribed angle is half the measurement of the central angle, or its intercepted arc, whichever way you want to think of it. So the conclusion that we're going to be able to draw here is the measure of an inscribed angle is half the measure of its intercepted arc. Oops, I can't spell arc, not ACR. So the converse of that would be to say that the measure of an intercepted arc would be twice the measurement of an inscribed angle. That's one of the properties of angles inside of a circle. The measurement of an inscribed angle is going to be half the measurement of its intercepted arc, or the measurement of an intercepted arc is going to be twice the measurement of its inscribed angle. But that's it for this demonstration. If you